following network, find the S matrix. Here S11 is 100 minus 50 divided by 150, which is 1 by 3. So S12 is given as S12 S21 is equals to 2 times 100, that is 100 divided 200. See, this is 100 by 150. So 2 la 3 ja, so 4 by 3 is the perfect answer. So similarly S22 is also equals to S11, hence option A is correct.
Value of the determinant ABC, M and P and XYZ is given as K, and we have to find the value of the determinant 6A, 2B, 2C, 3M, N, P, 3X, Y, Z. Let us use properties of determinant. Now what I do is I'll take 3 common from the first row, so which can be written as 3 times of 2A, M, X, 2B, N, Y, 2C, P, Z. Similarly, we can take 2 out of first row, so 3 into 2, then it will be A, B, C, M and P, X, Y, Z, which is nothing but 6 times of K. That is option D. We have to find the probability of guessing 6 questions out of 10 in an examination if each question consists of 4 options. So if each question consists of 4 options, there will be only one correct answer. So probability that the answer is correct is 1 by 4, and the probability that the answer is wrong is 3 by 4. We have to select 6 questions out of 10. So the total number of questions are 10, and we have to select 6 questions. Exactly 6 or more. So we have to check P of x greater than or equal to 6, which is 10C6 into 1 by 4 raised to the power of 6 into 3 by 4 raised to the power of 4 plus 10C7 into 1 by 4 7 3 by 4 cube plus similarly 10C8 10C9 and 10C10 1 by 4 raised to the power of 10 3 by 4 raised to the power of 0. If I simplify, the value will be 0.09, which is option B.
Following is not valid CDF. CDF is nothing but a cumulative distribution function, which is nothing but a probability distribution function. Here, probability distribution function is monotonically increasing because it is the probability of events, so it is monotonically increasing function. See, if we observe this property in the given figures, option A is correct because it is increasing, it's not decreasing anywhere else. Here comes to option B, the function is decreasing and then after increasing. So option B is not a valid cumulative distribution function because it is not satisfying monotonically increasing property of the distribution function. So option B is not valid CDF. Consider the matrix P, which is given as -31, -20. The value of EP is. Here find out the transition matrix E power Pt and substitute t equals to 1. E power Pt is nothing but Si minus A, Si minus P whole inverse. Okay, inverse Laplace transform. Then we will get option as D.
We have to find whether the integral 0 to 1 dx by x square plus root x converges or diverges, or whether it is oscillatory. We can write this as 0 to 1 dx by, I'll take root x common. If I take root x common, it will be x root x plus 1, and this can be written as 0 to 1 dx by x power 1 by 2 into x power 3 by 2 plus 1. This can be written as 0 to 1 x power minus 1 by 2 by x power 3 by 2 plus 1 into dx. Now clearly if we integrate this, it will be a constant value. Let us suppose some k. You can substitute x power 1 by 2 as some t and you can evaluate the answer. So it will be a finite value that is constant. So it converges to A, option.
In circuit, we have to find out the gain at very high frequencies. At very high frequencies, the reactance of capacitor is nothing but 1 by omega c. Assume omega is infinite, sufficiently large. So Xc is going to be 0. That means capacitor acts as a short circuit at very high frequencies because reactance is almost negligibly small at high frequencies. So now at high frequencies the network becomes a simple inverting amplifier whose gain is feedback resistance divided by input resistance, that is R1. So gain is nothing but minus feedback resistance is parallel combination of R2 and R3 and the input resistance is R1. Hence option C is correct. MOSFET is to operate at ID equals to 0.4 milliamps and GM is equals to 1 milliamp per volt. If K dash is equals to 50 microamps per volt square, then required W by L ratio is. Here we are neglecting a channel length modulation, that's why lambda equals to 0. So ID is equals to 1 by 2 K dash W by L VGS minus VT whole square. Now here we know in order to decide W by L we have to know K dash. We know ID, we know K dash, we have to know VGS minus VT. So if we are able to express VGS minus VT in terms of the known parameters, then we will be able to calculate the W by L ratio. So GM is equals to 2ID divided by VGS minus VT. So VGS minus VT is equals to 2ID by GM. This is this. So which is 2 into 0.4 divided by 1 milliamp. This is milliamp. So this is gets cancelled. 0.8 ohms VGS minus 50. So 0.4 is equals to 1 by 2 50 into 10 power minus 6 W by L and 0.8 square. If we solve this expression, we will get W by L ratio, that is aspect ratio, is nothing but 25. That is option C is correct. The MOSFET has the following parameters, that is the K is equals to 0.0005 amps per volt square and its Thevenin's voltage, that is threshold voltage is 1.75 volts. The maximum value of the drain resistance for MOSFET to remain in saturation. See, the condition for the MOSFET to remain in the saturation is the drain to source potential must be greater than or equals to VGS minus VT. Here the VDS is equals to 30 minus ID RD plus RS. Here 30 minus 1.5 RD plus 2, which must be greater than or equal VGS minus VT. Here we know ID is equals to K into VGS minus VT, which is equals to under root of ID by K, which is 1.5 into 10 power minus 3 divided by 5 into 10 power minus 4 under root. So if we do this one, RD is less than or equals to 25.26 divided by 1.5, which is equals to 16.85 kilo ohms. So that is option A is correct. 16.5 kilo ohms, that is not 20k, so option A is correct.